Alright, good morning guys, or good afternoon, or good evening, whatever it is for you guys. Today we're looking at Unit 6, Lesson 1, which I think is going to be it should be a review lesson for us, and hopefully we'll get through this pretty quick. Our learning target today is I understand the inverse. Remember, inverse is kind of like the opposite relationship between squares and square roots. We're looking at how squares and square roots work together, and how they are inverse relationships, just like addition and subtraction are inverse relationships, and multiplication and division are what we call inverse, have an inverse relationship. We're looking at how squares and square roots have an inverse relationship with each other. So let's talk about, well, what is a square root? What is a square root? Well, if we type in here, we say square roots. What is a square root? Let's ask, what is a square root? It tells us a square root of a number. Let's type this in. What is a number that produces a specified quantity when multiplied by itself? Which is that's what a square root is. And most of us know that. It's just kind of hard to put that into words. A number that produces a specified quantity when multiplied by itself. That's what a square root is. So if you want to write that definition down, it's a number that produces a specified quantity when multiplied by itself. A number that produces a specified quantity when multiplied by itself. Specified quantity. Can't type this morning. So, when we look at perfect squares, these are our rational square roots. When we kind of look at our perfect squares, what are some of our perfect square roots that you guys looked at? Can you think of some of those? Like 81. What's the square root of 81? That's 9, right? What's the square root of 36? 6. Square root of 100? 10. Square root of 4? 2. Square root of 64? That's 8. Square root of 16? That's 4. Those are our perfect squares, right? Those are the ones that come out to nice whole integers. We can also make these plus or minus because we know that a negative times a negative is a positive. So we know that. So these are plus or minus. Because negative 8 times negative 8 is also 64. If we look at down below, it says imperfect squares. These are, remember, imperfect squares. These are irrational numbers. So can you guys think of what are some imperfect squares? Those are like the square root of 10, right? So the square root of 10, we could estimate it, even though we don't know for sure what exactly it is without a calculator. Even with a calculator, all we can do is really round it. Because remember, it goes on forever without ending, without repeating or ending, terminating. So the square root of 10, we know it's more than 3 because 3 times 3 is 9. It's just slightly more than 3. So we might estimate it at 3.1. Let's say 10 square root is 3.16. So probably a better estimate would actually be 3.2. Square root of 50. That's just more than 49. So we might say like 7.2. So 50 square root. Oh no, that one rounds to 7.1. So I was off. That one's just 7.1. because that's a bigger number. So since it's still 1 away from 49, but it's larger, so it's the separation between 49 and the next square root, 64, is more than between like 9 and 16. So come up with some more of your own, guys, and then estimate them and test them. You know, come up with a few of your own, like square root of 20. So that one's kind of in the middle, right, between 16 and 25. Remember, we did this earlier in the year. We put them on number lines. So that one's kind of in the middle, but it's closer to 16, so it's probably like 4.4, maybe. Okay, so if we do square root of 20, 4.47. So that one actually would round up to 4.5 if we were doing to the nearest tenth. So these are kind of our imperfect squares. These are our irrational numbers. Okay, so what's the relationship? What's the relationship between a square and a square root? Well, what happens? Well, this is an equation, x squared equals 36. I'm going to write it larger. X squared equals 36. How do I evaluate? How do I solve this equation? How do I get x by itself? How do I cancel out this x squared? What's the opposite of x squared, or inverse of x squared? Just like if I had 2x, a lot of people say divide by 2. But no, you don't divide, because if I did 2x equals 36, that would be division of 2. I divide by 2. This isn't 2x, it's x squared. So on this one, I have to do the square root of both sides. That cancels the square, so I have x equals the square root of 36. This is what we call radical form, when it still has the radical sign, the square root. Or we could put it in decimal form. In this case, it's a perfect square, so it's just square root of 6. So how do we do this one? Well, we do the square root, so x is equal to the square root of 10. That's radical form. We could estimate it. Again, we'd only be able to estimate this because it's an irrational number. So all we do is estimate it, and we'd say, well, this one, I think we did it earlier, is about 3.1. About. It's an estimate, right? It's an estimate. It's about 3.1. Exact answer would be the radical of 10. Alright, let's do a few practice problems here, guys. I told you this would be kind of a short lesson. Square root of 25, remember that would be plus or minus what? 5, right? Square root of 45, we could estimate that. We could say that's plus or minus. It's more than 6, but it's less than 7. So maybe like 6.7. 45 square root. Yeah, 6.7. That was a good estimate. On this one, we do the inverse operation of a square, which is a square root. And we get x is the radical of 81, or x is equal to 9. Plus or minus 9, because plus negative 9 times negative 9 is also 81. Here we do the square root. So we have x is equal to the radical of 32, or x is about, if we round it to the nearest decimal, we'd say x is about 5.7. How about this one? It says this square is 49 square feet. Area is 49 feet squared. Well, how do we find area? Area equals side squared. So side times side is 49. So we would do this square root to find that one side is 7 feet. So each side is 7 feet of that square. And last but not least, the last problem is pretty much the same thing, right? Except this one says the area of a square is 50. What is the length of one side? Both in radical and in nearest feet. That's why I did that on me. For some reason I can't get this. So on this one, we'd have to do with it. Side squared is 50, because the side times side is the area of 50. square root that, square root that. So we know in radical form, each side is 50 square root the square root of 50 feet. That's in radical form. Or we would estimate that each side of this square is about 7.1 feet. Let's see how close we were. I think we did this one earlier, didn't we? 50 square root is about 77.1 feet. Okay, so that is our lesson today, guys, and it's hopefully it wasn't too complicated. It's understanding the inverse relationship between squares and square roots, and how they work together, and how they are they inverse or they cancel one another out. Let me know if you have any questions, guys. Enjoy your day, enjoy your weekend, and let me know. Please let me know if you have questions on this or on the other stuff, the inequalities and the repeating decimals, the fractions, the stuff we have the quiz on. Signing out today, guys. Hopefully you have a great day. Mr. Urschel.